All right, guys, here we go. Online quiz 20, it says use differentials to estimate the value of the cube root of 62. Really, when it says differentials, it's really like saying use the linear approximation, use a tangent line. So my equation is y equals the cube root of x. Can you guys think of the closest perfect cube root that's really close to 62?
$64.
Yeah, 64. The cube root of 64 is 4. So this is my point. And now I need a slope. So there it is. I need my tangent line at 64. So I'm going to go y prime equals, remember this is the same thing as x to the 1/3. 1/3 x to the negative 2/3 because I subtracted 1. So now this is y prime equals 1 over 3 cube root of x squared. And I'm going to plug in a 64. So let's see, y prime of 64 equals 1 over 3 cube root of 64 times 64. Well, I already know the cube root of 64 is 4. So 4, and then I have another one, 4. 4 times 4 is 16, and 16 times 3, 16, 32, 48. I want to say it's 48. So here's my tangent line. Y minus 4 equals 1 over 48, x minus 64. So what am I going to plug into this x value? I'm going to plug in a 62 right there. So my y value is approximately, and this is my approximate y value there, 1 over 48. Let's see, 62 minus 64, that's going to be a negative 2 plus 4. Let's see what that is. Negative 2 divided by 48 is 0.04 or negative 0.04. I'm going to add 4 to that. Or let me see. Negative 2 divided by 48 plus 4. So I get, oh, what's going on here, guys? Sorry. I lost my, there we go. I get 95 over 24. And there it is, guys. How do we feel? Anything crazy there?
Yeah.
Okay. Same thing here, guys. It says use differentials. So you're just going to do the same thing. Notice there's a fourth root there. So my equation is going to be the fourth root of x. And they're being kind of nice to us, kind of. They're using 16.5. So I bet you 16 has a perfect fourth root, and it does. I believe it is 2. Let's see, 16 times, let's see, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. Yep. So if I put the number 16 in there and I get the fourth root, I get a 2. So this is my point. Now I need a slope because I need a tangent line to approximate the 16.5. So y equals x to the 1/4. And here's my derivative. 1/4 x to the negative 3/4. I'm going to rewrite this. So y prime equals, well, I guess I could rewrite it right here. 1 over 4 x to the, hold on, there's a little ant on my screen. Get out of here, ant. There we go. 1/4 x to the 3/4. And I'm going to rewrite it and write it like this. Let's see. 4/4 root of x cubed. All right, so now I want the derivative evaluated at 16, because that's what I'm finding my tangent line. So I'm going to write 1 over 4, fourth root, and I'm going to write 16 times 16 times 16, because it says cubed. And I already know that the fourth root of 16 is 2. 2 times 2 is 4, and 4 times 2 is 8. So I have 1 over 4 times 8. And let's see, 8, 16, 32. I believe that's 1 over 32. Now that I have that, I'm going to write y minus 2 equals 1 over 32 x minus 16. And I'm going to plug in 16.5 in there. So you can already see it's going to be a half, right? So what do I get as an approximate? I'm going to type it into my little calculator. 16.5 minus 16, that's a half. So 1 over 32 times a half plus 2, and I get 129 over 64. Nothing crazy. I think we're doing pretty good so far. On this one, it says use differentials to estimate the value of sine 26 degrees. This is awk. This is awk. By awk, I mean awkward. You guys probably don't use that anymore. That was a 90s thing. Like, oh, that's awk. All right. 26 degrees. So my equation has to be sine, and we rarely ever use degrees. So let's convert it to radians. Let's see, pi over 180 x degrees. And we're going to use, what are we going to use? Well, we're going to use the one that's perfectly or closest to sine 30 degrees. So my coordinate is going to be 30, comma, well, the x, because the x is a degree, comma, let's see, 30 over 180, 3 over 18, that's pi over 6. Sine of pi over 6 is a half. Does everyone understand how I got my coordinate?
Yes.
Okay. Does everyone understand why I put pi over 180? Whenever we're doing calculus, guys, we want to not do anything with degrees. We want to do everything with radians. Because they put degrees, it forced us to work with degrees. So here it is. I had to create an expression that would give me a radian instead. So when I plug in the 30 degrees, I will get a radian. 30 times pi is 30 pi. 30 pi divided by 180. The 180 has a degree symbol there. The degrees cancel out, and you just have a radian. You have pi over 6. So you want to work with specifically with radians. So here we go. My derivative. The derivative of sine is cosine. So cosine, notice I left some space there. That's for a reason. Cosine pi over 180, little degree there, x, a little degree there as well, times chain rule, times pi over 180. And pi over 180 on the outside is just a number now, so don't put the degree symbol on the bottom. All right, so now I'm going to plug in, what am I going to plug in? The 30. So y prime of 30 degrees, pi over 180. And then cosine of 30 degrees, 30 times 1, that turns it to pi over 6. Cosine of 30 degrees is just square root of 3 over 2. So when I multiply that, you get square root of 3 with a pi on it. I like to put the pi on the side, guys, because sometimes the pi looks like it's under the radical. And then 180 times 2, that is 360. Oh, you almost messed me up, miss. So 360. I'm in question, I don't know what number that is. Question 3. Viacana says hi. Viacana said that she didn't want to come to school today. No, she didn't say that. She didn't say that. I'm making up stuff. So there we go. There's my slope. And we're not going to have y minus, I think she said she overslept. Y minus, did I say that correct, Viacana?
Yes.
I'm not trying to start any fighting words here.
No, it's okay.
X minus 30. Okay, there is where I'm going to plug in a 26. So here I am. I'm going to change my color to 26. I'm going to put a 26 there. Let's see how much of this we can do without a calculator now. Y minus half equals pi square root of 3 over 360. 26 minus 30, that's a negative 4. 4 goes into 36 9 times. So this has to be, y is approximately, let's see, negative 9. Nope, that's in the bottom. pi square root of 3. That's a 3. It just came out silly. Negative, and then 90 in the bottom plus half. Do I see that? There it is. All right, let's keep going. So this one says take ln 6 equals 1.79. So that's kind of like a point. They already gave us a point there. So the point they gave us, well, it's obvious that they're doing y equals ln x. So, and I really should, there we go. So they're doing y equals ln of x. And the point they give us, let's see, 6 comma 1.79. And really they should be giving us more than 2 digits. That's a bad habit, but no big deal. So we're going to estimate ln of 6.2. So here we go. Y prime equals 1 over x. And so we're going to find that. So y minus, well, I guess first we got to find our slope, right? Y prime of 6 equals 1/6. So there's my slope. So now I'm going to write y minus 1.79 equals 1/6 parenthesis x minus 6. And now what am I going to put? I'm going to put 6.2 right there. Since I have all decimals, I'm going to use my calculator. Y is approximately, and I'm just going to go 1/6 times 0.2. So let's see, 1/6 times 0.2. And whatever that is, I'm going to add 1.79. Oops, I messed up. And I got 1.82333. Did you say that's wrong or that's whack? Oh man. Oh, there's a little ant on my little coffee. Sorry, ant. There, he's out. I didn't kill him, miss. He's just part of the earth, doing his thing. I'm glad that you would let the ant live. Would you let the cockroach live? Okay, good. Did you really? Everyone's just trying to survive. All right, so on this one, guys, we haven't really talked much about it because, well, there's a specific reason why we haven't talked about it. So they want us to use delta x. It's very simple, so you'll see what I'm talking about right now. So we have this equation, y equals 5e to the x cosine x. And you can see here that they have dy's in there. All the answers are dy's. So we're going to take a derivative, but we're going to write it like this. dy dx equals, and then look, you're going to do product rule. So you're going to say first, 5e to the x times the derivative of the second. The derivative of cosine is a negative sine x plus second cosine x times the derivative of the first, which is just 5e to the x. And rewriting this, you're going to say dy dx equals, let's see, I'm going to write this first because it's positive, 5e to the x cosine x. So a lot of you guys probably like it this way anyways, minus 5e to the x sine x. And now what I'm going to do, guys, I'm going to put all this in parentheses, and I'm going to treat the dy dx like a fraction. So I'm going to say dy over dx. So I'm going to write dy by itself, and I'm going to write all this in parentheses, 5e to the x cosine x minus 5e to the x sine x. Close it, and I'm going to put a dx there. Now, they told me to use the difference as delta x and not a dx. So all I'm going to do is replace the dx with a delta x. By the way, dx and delta x are almost the same. Dx is used whenever you're talking about a very, 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 very small change, practically zero. Delta x is just used whenever you're finding the difference of something. So the difference between something and something is usually a number that's not zero, like 1 or 5 or 10. So what's the difference? Dx is used for very, very, very small. They're called infinitesimals. You've probably read it in a calculus book somewhere. Oh, I forgot you guys don't have calculus books. If you read it, The dx, the dy, well, obviously, right? Like we're finding very, very small changes because the dy dx is it's an instantaneous rate of change. So we're talking about very, very small. Whenever you use the dy and dx's, we're talking about small changes. And whenever you use delta x, you're talking about changes that are bigger because the dy and dx are practically zero. We're talking about small changes. Anyways, there it is. There's my little mini essay. Let's look for that answer. Do you see it anywhere? Let's see. All right. Here we go. I'm going to try my best to explain these guys. Look what it says. Consider the function f of x equals x to the 3/5. Underline the word approximate. Approximate the change in f as x changes from 242 to 243. The key word is approximate. If they were to tell us to find the exact, well, all this means the change in f. That really just means the change in y. If we want to know the change in y, all we will have to do for the exact, let me write exact, is go f of 243 minus f of 242. And this will give me the exact change in y. Does that make sense to you guys? But do they want exact? No, they want approximate. So because they want approximate, here's what you're going to do. I'm going to take my function and I'm going to take the derivative. So I'm going to write it like this. dy dx equals, so the derivative of this is 3/5 x, and then I'm going to subtract to the negative 2/5. Do you guys agree? I'm going to rewrite it again. 3/5 x to the 2/5. I'm going to leave it right there. And then I'm going to write it like this. dy is equal to 3/5 x to the 2/5. Notice I put a giant parenthesis, dx. This will be my approximate. See, because dy is like the change in y. So I'm going to use what x value? I'm going to use the x value that I'm currently in. And the dx is the change in x. So my dy is equal to 3/5 parenthesis 242 to the 2/5 times, I'm going from 242 to 243, so it changed by 1. And in case you're wondering, how do you calculate that in case it's not, it's different numbers, you just go 243 minus 242. All right, I'm going to take my little calculator. I'm going to go 3 divided by, and I'm going to use parentheses, 5 times parentheses 242 raised to the power, another parentheses, so it knows that it's 2/5, close, 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 close. And if I did everything correctly, darn it, I didn't do everything correctly. It's a small number though, I know that much. What did you get, Godinez? Huh. All right, hold on. Did I do my derivative wrong? 5/5, 3/5, negative 2/5, bring it down. 3/5. Approximate the change in f as x changes from 242 to 243. 1/15. Okay, we got the answer, guys. For whatever reason, our calculators did not change our fractions to decimals, but we did in fact get 0.06666667.
Shav, I have a question.
Yeah, ask.
So since you put your x as 242,
Mhm.
can you put like 242 or 243, or how do
No.
you like decide which one to put?
Always put the original, like what it was originally, because it says the word approximate, so you are always going to put what it was originally, the original value. And then the dx is always by how much the original changed. You know what I mean?
Yes.
And you're always going to be doing that. And we got another perfect problem that does the same thing again on question 7. So check it out, guys. A spherical ball bearing will be coated by 0.04 centimeters of protective coating. If the radius of this ball bearing is 7 centimeters, approximately how much coating will be required? All right, so let's read it again so we can understand the concept of what's really happening. A spherical ball, so a ball bearing just means like a sphere. Trying to make it 3D there. Will be coated by 0.04 centimeters of protective coating. So I have paint, and that paint is 0.04 centimeters thick. All around. It's all around it. If the radius of this ball bearing is 7 centimeters, approximately how much coating will be required? Underline the word approximate. So let's see if we understand. If they want it exact, they're not asking for exact. But if they wanted exact, it would be 4/3 pi times the radius, which is, let's see, 7 centimeters from here to the edge, but I have to add how much for the other outer coating? So 7.04, and this is cubed, 4/3 pi r cubed, minus 4/3 pi times 7 cubed. This will give me the exact volume of coating, because the amount of coating I have is 0.04. So does everyone understand this equation for exact? Be honest with me. Virtual class?
Did you take kind of, but not really?
Okay, let me see if I can explain it. Because this is a tough subject. This is the volume with the coating. This is the volume without the coating. Volume without coating. If I subtract them, I'm literally just getting the volume for the coat. Because the coating is adding 0.04 to my radius. Does that make sense, Mazuka?
Yes.
So this is the exact. Now, do they want exact? No, they don't want exact. If they wanted exact, this is what we would do. They don't want exact. So what are we going to do? Volume equals 4/3 pi r cubed. We're going to take a derivative. Ask. Yeah, because the coating has a thickness. You know what I mean? So here we go. I'm taking the derivative with respect to r. dV dr equals 4 pi r squared times dr times dr. dV, which is like the change in volume, is 4 pi r squared dr. Where, remember, Tiff, what did we say we were going to use for r? The original. So r is the original. And what is dr? Perfect. 0.04. The 7.04 minus 7. So here we go, guys. dV equals 4 times, they tell me to use 3.14 times 3.14. You need a calculator. There's no way around it on this one. Times my current radius, 7 squared, times 0.04. I'm going to type that into my calculator, and I'm going to see what I get. 4 times 3.14 times 7 squared times 0.04. I got 24.6176. Mazuka, did we get it?
I'm just still a little confused as to why we're using volume for like a coat.
Because coating has depth to it. We're not talking about surface area. It has depth to it because look, there's 0.04 centimeters of protective coating. So there's like, I don't know what word, girth. It has thickness. The coating has thickness to it. So because it has thickness to it, there's a volume instead of a surface area.
Okay.
That makes sense?
Yes.
All cars have a coat. All vehicles have paint, and that paint has a thickness to it. So you can actually calculate the volume of the paint in your car if you wanted to. It's very slim. It's a very small amount, but it still does. It has volume, guys. Well, you got, what do you got? Like you got like primer, and then you got the color, and then you got a clear coat. You got to get something that measures thickness. We're talking about very small amounts. There are devices that do that. And
Maybe
not all the cars uniform either. You know what I mean? Like the paint is thicker in certain locations than others. Unless
guess-
you got like a really good paint job. What's up?
I guess I was confused because we were using the radius of the entire like sphere.
Oh, that's only for the exact. See, I found the volume with the coat, and I found the volume without the coat. Where it says exact,
Yes. Oh.
and that gives me the volume of the coating, because I have volume with coating and volume without coating. So if I subtract them, that's going to give me my exact volume of how much I have for coating.
Oh, okay.
You know what I mean? That's not what they were asking though. But
Yes.
you know, I don't want you guys to be robots, so that's why I bet you that this exact amount is super close to this approximate amount. They're really close, really close. You're gonna do it? Yeah, tell me how close they are. Well, Dina's is calculating the exact amount. While she's doing that, I'm gonna take a sip of coffee. Yeah, use 3.14. No, you can use the exact one. It's fine. Okay, what you get? Look how close it was to the real one. Super close. What was the exact? The exact was 24.7585 cubic centimeters. That was the exact. So look how close we are. You got it heck super close, man. These are the worst answers. Do not choose A and D, guys. Those are the worst ones. All right. What's the next question? Give the derivative of E arc sine 9x at the point where x is 1/18. Okay. They're not even asking anything. They're just asking for derivative, guys. All right. So we can do that. First, let me rewrite the equation. F of x is E. In case you don't know what arc sine is, that means inverse. So inverse sine of 9x. All right, let's see if we remember. The derivative of E is itself. So E to the arc sine of 9x. And then I got to do the derivative of arc sine. Do you guys remember the derivative of arc sine? Perfect. 1 minus, this is your U, 9x squared, and we're still not done, times the derivative of 9x, which is 9. There it is. I'm going to plug in what x value? 1/18. So let's see what that is. Well, I guess let me make it pretty first, right? So let's see. I'm going to put the arc, this first in the front. 9 over square root of 1 minus 9x squared. And I guess I can put it right here. E arc sine of 9x. All right, there it is. Now I'm going to type in 1/18 and let's see what I get, guys. F prime of 1/18 equals 9e arc sine, and then 9 times 1/18, that is going to be a half. So you're going to need a little bit of pre-calc, not that much, just a little bit. All over, sorry about that. Square root 1 minus, let's see, 1/18 times 9, that's going to be another half. And I'm going to square that. Well, let's see. I'm just going to circle this, guys. Here comes your pre-cal. And it's not extreme pre-cal, just a little bit. Actually, let me get rid of that E there. I'm just evaluating this. That means sine of what angle is equal to a half. That's what it means. So which is the very first one you hit? Perfect. So this is going to give you pi over 6. So let's see. 9, I only see one with pi. Oh, there's two of them. It's between these two there. 9e to the pi over 6 over square root of 1 minus 1/4. So let's continue to simplify. And then that turns into the square root of 3/4. So now I have 9e to the pi 6 over square root of 3 over 2. And then you can move that 2 up. 9 times 2 is 18. So where do I write it? Did I write it over here? 18 e to the pi over 6 over square root of 3. And they have it rationalized. So let's multiply this by square root of 3 over square root of 3. And we're almost there, guys. 18 e to the pi over 6 square root of 3 over 3. And 3 goes into 18. 6e to the pi over 6 square root of 3. There it is. I don't like this. Well, okay, that's fine. 6 square root of 3e to the power over 6. But sometimes that radicand stretches ever so lightly. And that's why I like putting the square roots at the very end and not in the beginning, because just in case the square roots stretch out. And there it is, guys. It was a little tough, but not too extreme. All right, here we go. I'll do this one in a different color. Find the derivative. So they're just doing a derivative here. Do not tell me that the derivative of this is 3x, 9x plus 1 to the power 3x minus 1 times 9. Do not do that. There's an exponent there, and it has an x on it. We got to bring it down. So here's what we're going to do. Let me choose blue. ln, ln. So now I have ln of y. We're going to have to do it implicitly and bring that 3x down. 3x ln of 9x plus 1. So now I'm going to take a derivative. So we're going to have 1 over y dy dx equals, and I got to do product rule. First times rid of the second. Plus second times the root of the first. Let me simplify it. In a little bit, we're going to multiply by the y there. 3x times 9, 27x over 9x plus 1 plus 3 ln of 9x plus 1. Okay, I don't see anything crazy there. I'm going to multiply by y, the whole shebang, times y times y. So now you're going to have dy dx equals, and I'm going to put my y there, and I'm not going to distribute it. I'm going to leave it alone. So catch up. Now I know what y is because I have it over here in green. Y is simply 9x plus 1 to the power 3x. So there it is. Replace that y with that number, and let's look for it. I want to say it's a. 3 ln minus plus 1. Yep. You see how we did it? In case you need notes for this, go back to your log. I don't remember the notes number, but this is from your log rules, log notes. All right. Is this the last one? Given that this function, negative 3x cubed minus 2x minus 9 is invertible, and verify that f of x is invertible. Okay, okay, pretend that minus 9 wasn't there, guys. This would be an odd function. All odd functions are invertible. What does invertible mean? It has an inverse, and that they're 1-to-1. It has an inverse, it's 1-to-1. That minus 9 just does a horizontal shift down 9. Yes, it's still invertible. It's still 1-to-1. All odd functions are invertible, and then if you just have a shift, yeah, then that function is definitely going to be invertible. It just means that they have an inverse, and it does. It has an inverse. If so, find the equation of the tangent line to the inverse at the point where x is negative 14. Now look, they're being very nice to me. They want, what do they want? The tangent line for my inverse. I need a point. My point is negative 14 comma 1. And I need a slope. I'm going to find the derivative of this function. This is my original, not my inverse. And I'm going to plug what x value? Am I going to plug in a 1 or am I going to plug in a negative 14? A negative 14. Wait, no, a 1. Right? Let me see if I can write it.
Oh, yes.
And then you do the reciprocal. I'm gonna find f prime of 1. Find f prime of 1. Then take reciprocal for slope of inverse function at x equals negative 14. All right, here we go. So hopefully none of this is new, guys. These are the hard ones. These inverse ones tend to be the toughest ones on the AP exam. F prime of x equals negative 9x squared minus 2. F prime of 1 equals negative 9 minus 2, so negative 11. And I'm going to take the reciprocal, and I already have a point, so here we go. Y minus 1 equals negative 1 over 11 x plus 14. And it looks like they're being kind of nice to me. No, 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 no. Y minus 1, negative 11, x plus 14. It was letter E. And there it is, guys. And now we're good.